This will be two separate. Again, apologize for that. We had an internet connection problem. So we'll go back to question 6. Let me share my screen. There'll be two separate videos. So everyone should be seeing my my screen now. Let's see, I got an email. Maybe from no. All right, so that's question 6. Does anyone have any question on question 6? Okay, so let me go over it again. I can even do it on another slide. Let's go to, we'll do the same question here. So let's, question 6. So we have our SN2, the SN2 product is the easiest one. So if we have our bromine here, we have an OH group, it's concerted. So it all happens in one step, right? So your SN2 is going to be your E01. It's all concerted, happens in one step. That's your SN2. Your SN1, this is stepwise, right? So the rate determining step is going to be the bromine leaving. So the bromine goes, that's step 1, right? So once that bromine leaves, then we have this carbocation. But this is a secondary carbocation, right? And we have a hydrogen here. So if we do a 1,2 hydride shift, you know, your 1,2 hydride shift, then we're going to create a tertiary carbocation. Now we have a tertiary carbocation here. Now the bromine can come in, not the bromine, the OH group, and you get your compound. This is your SN1. So question 7, it says draw the 2 possible alkene starting materials. You have some type of cyclo group, and they're adding, it says true with mercury, that compound, and we saw this before. So we're gonna have this one. Oh, let me redraw that. That one, and then we could also have have this one. And the starting material, this is your answer, but the starting material was this right here. But you would start with these right here. So this is your, I guess this is your ending, this is your product. So this is your product. And here's your starting materials. So question 8, I think we're on question 8. Yeah, question 8. It's asks you to calculate the oxidation number. Hopefully this is really easy for you now. Once the oxidation number here, you can call that the alpha carbon. So recall that these 2 electrons from this bond are going to go to that oxygen. So we're not going to consider that. This carbon is going to take them both. And there's 2 electrons here. One's going to go here. One will go here. Again, there's 2 electrons here. One goes here and one goes here. Now we have to count them all. We have 1, 2, 3, 4. So 4 minus 4 equals 0. And these are the 4 that we counted. And carbon should be 4. So 4 minus 4 is 0. So the reason why it splits it with the methyl groups is because they're both the same. They're both carbons. But if we look at the oxygen, let me get my periodic table out. Oxygen is more electronegative, right? So oxygen, you have to think about it as like an ionic bond when you think about these oxidation numbers. So if oxygen is more electronegative, then it's going to take those electrons. So think of it, and I know it's not an ionic bond, but that's what they talk about in the textbook to how to think about it. So, we think about electronegativity. Oxygen will be more electronegative. It's going to have more of that electron density. So it's going to take both of those electrons. Since carbon and carbon are equal, they're both going to split. All right, so we'll do one more question. If you go from a ketone to an alcohol, that's going to be a reduction. Oh. I do have a medical appointment I need to go to, so I'm sorry, I do need to leave. That's going to be a reduction right there. Let's see what question that was. That was question 9. So we'll come back to this tomorrow. We'll finish this tomorrow, and then we'll move on to chapter 13. So let me see when the homework is due. The homework is due on July 9th. So you have until Saturday, July 9th to get the homework done. And we'll have it all done tomorrow. All right, you're welcome. I apologize, I do need to go. Thank you everyone and have a great day.